Number 8, write the standard form of the equation of and the general form of the equation of a circle that has a radius 9 and a center of 0, 0, and then graph. So again, standard form is quantity x minus h squared plus quantity y minus k squared equals whatever the radius is squared. And the center is the order pair hk. So for this one, if the center is 0, 0, you're just going to have x squared plus y squared. And if the radius is 9, then in the equation, it's going to be what? 81. Now, essentially, what the general form is this quantity multiplied out, this quantity multiplied out, and the equation set equal to 0. Since the center here for this one on number 8 was 0, 0, there's nothing really to multiply out. The only thing to do would be say x squared plus y squared minus 81 equals 0. That would be it. So so, and then was there any trouble using the graphing tool to graph?
No.
Okay, so that's it essentially. And as far as, again, going to general form, and I apologize, I woke up this morning with a sore throat, and so my voice is a little raspy. It's multiplied out and set it equal to 0.
Okay.
All right. Another one. So if we were to look at, I'm just going to look at 9 real quick. 9 has a radius of 2. The center HK is 0, -2. So in the standard form, you would be looking at here, since the x coordinate is 0, you're just going to have x squared plus, but this will be quantity x plus 2. And I didn't mean to write x, that was supposed to be y. Y plus 2 squared, and the radius was 2, so 2 squared would be 4. So to get it to general form, you'd have x squared plus, now multiplying this out, since it is y plus 2 times y plus 2, the quickest way, since the outer and inner products, when you FOIL it, are going to be identical, and they're going to be that times that is y times 2. You can say first term squared, product of the 2, and then doubled it, because you're going to get 2 of them. So it would be plus 4y, and then plus 4, and then equals 4. So the only other thing I could do is set this equal to 0. When I bring the 4 over to the left side, I'm going to have x squared plus y squared plus 4y. Those, when I bring the 4 over, you're just going to get 0, so equals 0, and that would be your general form.
Thank you.
Yep. 10 and 11. 11 would be the one with the most algebra, and because you would have to multiply out both the quantity squared for x and the quantity squared for y, but the process is still the same. Multiply them out, combine like terms, set it equal to 0.
Okay.
All right. Any other questions in there besides those?
Can you go over number 20, please?
Yep. All right, let me get to 20. No, I was just looking here before I got to 20. I was looking at 12. And it's still the same process with 12. It just has a fraction. So you have to do some arithmetic with fractions. All right, so number 20. All right, so this one, turn the page. On number 20, we're going to find the standard form of the equation of a circle, which means you need to find the radius and you need to find the center to do that. And what you're given are endpoints of a diameter. So you're given 2 points on the circle, and you're told they are endpoints of a diameter. And these points are 1, 2, and -7, 4 for the problem I'm looking at. So if what basically you're going to end up doing here is using distance formula and midpoint formula. We're going to use the distance formula, find the length of the diameter, and then the radius would be half of that. So I'll call it not R yet, because that would be half of that. So we'll just say D for diameter in this case. Then is the square root of, so you want the difference of the x coordinates, just watch your signs. It would be 1 minus a -7 squared, plus then the difference of the y coordinates, and I'll go 2 minus 4 squared. So we'll simplify this as much as we can. That's going to be 8 squared, so that's going to be 64. This is going to be -2 squared, which then squaring it would give me 4. Now that's going to give me square root of 68, which I could simplify because it has at least a factor of 4, but I'm going to go ahead and just not worry about it, because I know at the end when I put it in the standard form of the equation, I'm going to end up squaring that number. So this square root's going to go away when I put it in there. So I'll just leave it as is. But I will say the radius will be the square root of 68 divided by 2. So take half of it. All right, so we've got that. Now the center is going to be the midpoint of the diameter. So we just use midpoint formula, and that would give me my center. So that's going to be, when you're finding midpoint, average up the endpoints x coordinates and the endpoints y coordinates. So you would have 1 plus a -7 divided by 2 for your x coordinate, and you would have 2 plus 4 divided by 2 for your y coordinate. So that would end up being, now that's going to be what, -6 divided by 2, which would be -3, and this would be 6 divided by 2, which would be +3. And so that would have to be your center. So putting it in the standard form, we're going to have x, since that coordinate's negative, we'll have x plus 3 all squared, plus then y minus 3 all squared. And then this part of the standard form is the radius squared. All right, so here was our radius. If I square top and bottom, squaring the top would give me 68, and squaring the bottom would give me 4. So that would reduce to what, 17. So 4 will go into 68 17 times, and there's your answer.
Okay, thank you.
You're welcome. Anything else on 2-4?
I didn't have anything else.
All right. All right, so there is a quiz covering 2-3, which was equations of lines and circles, and it was it is assigned, and I had also assigned the chapter 2 test. So you're going to need to take that quiz and make sure you do well on it before you take the test. So, and this happened last night with my on-campus college algebra course. They're kind of in the same position you are. They were through 2-4. A couple of them had taken the quiz, a couple of them hadn't. But I needed to press on. So, which is, I mean, I got in, started into 3.1 with them. So same deal with you guys. Between now and Wednesday, definitely finish up the homework on 2-4 and take that quiz at least once. If you feel like, hey, I want to ask a couple questions on Wednesday before I take that test, that is fine. But I definitely need you to get through the homework at 2-4 and take that quiz. And but I do need to go on and cover 3.1. So if there's no other questions on chapter 2, I'm going to go ahead and start talking about 3.1.
Right.
All right. So which is really the start of college algebra. It's really the study of functions. I see one of my puppy dogs coming down the stairs. By the way, I have my buddy with me, so you can see her. Say hi.
Aw.
This is Miss Olive. She's our senior pup. She's a 10-year-old Shih Tzu. It's my kayaking. So we take our bigger dogs. We are trail dogs. So they're always on trails with us. She's a little too small. Sometimes we take her in a backpack, but she is our kayak dog. She loves to ride in a kayak. Function. All right, so 3.1. This is all about introduction. That's not an O. That is a U. Functions. All right. So college algebra isn't entirely all about functions, but that is the primary focus. And a lot of real world stuff can be modeled with functions, which is why we take the time to really study them. So how many have worked with functions before?
I think we have. Yeah.
You have?
Yeah.
Okay. So first thing we want to do is kind of get a handle on the concept, what makes a function and what makes it not a function. So I'm going to keep this like really simple. I'm going to first define, verbally anyway, something we call a relation. And what I'm going to ground it in is something you've already been working with. I'm going to call a relation a set of ordered pairs in which every x coordinate is related to a y coordinate. Just keep it really simple. Right? So that's going to be our first kind of definition. So I'm not writing it down, just verbally saying it's a set of ordered pairs in which there's some way that x coordinate is related to y coordinates. I'm going to call the set of all x coordinates the domain, like collective go all up, and I'm going to call the set of all the y coordinates the range. So then I'm going to say a function
Range was.
is a relation. So it's a specific type of relation. So right now it's a set of ordered pairs in which, okay, so what will make this a function? Well, we'll make this relation a function in which all the x coordinates are unique. All right, so I have a set of ordered pairs. If I have a set of ordered pairs and I'm asked, is it a function or not a function? I am just simply going to go through and make sure all the x coordinates are different. I have no two ordered pairs with the same x coordinates, so keeps it rather simple. So if I had, as an example, 1, 2, 3, 4, 5, 6, 7, 8. And I said, okay, is that a function? Yes, it's a function. All I can do is make sure all the x coordinates are unique. Let's do another one. I have 1, 3, 2, 3, 3, 3, 4, 3. Is this a function?
Yeah.
Yes.
Yeah. Yeah. Again, all that matters is all the x coordinates are unique. So the y coordinates could all be the same, which is what we were observing in that one. I had 1, 4, 2, 4, 1, 5. This is not a function. Simply because I've got two x coordinates that are the same. I got 1. Now, if I were to ask what is the domain, say, of this first one, I would say the set 1, 3, 5, 7. What is the range? It would be the set 2, 4, 6, 8. Again, keeping it simple, the domain is the set of all the x coordinates, and the range is the set of all the y coordinates. All right. So with this idea in mind, and I should note right now, and I'm trying to go quick here because I know we're on a short clock. There's a much more generalized definition, and we'll get to that on Wednesday in terms of defining function. But right now I'm just grounding it in something we've already worked with. So that is sort of looking at sets of ordered pairs. But if I move this idea to, say, an equation of two variables, what we were looking at in chapter 2. Let's just say I look at the equation y equals 2x plus 3. Now, so that's an equation of a line. We know that that has a slope of 2, a y-intercept of 3. But now I want to kind of view it in this term, this lens of function. And what I want to think of is inputting into x, and y is kind of the output, right? Or the domain value, and then its corresponding range value. And if I think about it inputting into x here, then the idea, is this a function or not, is simply this. Is it possible to put a number in for x, multiply by 2 and add 3, and get 2 answers? Because the whole thing, and I need to turn the page back, with function, at the end of the day, what makes it not a function? By saying I got 2 ordered pairs with the same x coordinate. What I'm saying here is 2 gets related to 4, but 1 is related to 4 and also what? 5. So this idea of I inputted 1, but I got 2 what? Corresponding outputs. Not a function. A function at its heart is I put one thing in and I get one corresponding thing out. If I get more than one thing out, not a function. It's just a relation. So back to this one. No, it's not possible. I put in any real number, just put in one number for x, multiply by 2 and add 3. I'm not going to get 2 answers. I'm going to get 1 answer. So this is a function. Its relation is taking number, multiply by 2 and add 3. So if I looked at y equals 3x squared plus 4x plus 5, all right, so there's a little bit more going on, but still at the end of the day, it's plug in a number for x everywhere I see x and do all this arithmetic, but there's still only going to be one answer. You're not going to get 2 answers. Ergo, this is a function. All right, so what kind of equation of 2 variables would not be a function? Maybe I look at x squared plus y squared equals 1. All right, so as long as I could come up with 2 ordered pairs that had the same x coordinate, then I know it's not a function. As long as every ordered pair I'd look at every x coordinate's unique, I'm good. But here it's pretty quick. I could find 2 relatively quickly. If I say let x be 0 and y be 1, but I could also let x be 0 and y be what? -1. So I've got 2 order pairs right there, which have the same x coordinate, but they're both solutions to this equation. Ergo, this is not a function. We okay with that idea?
Yeah.
Yeah.
Okay, so if I have an equation of 2 variables and I've established that it is a function, we have specialized notation for this. And this is what this looks like. Y equals f of x. And that's how this is read. F of x, or short for function of x. We are saying y is a function of x. Now you can actually use any letter here, especially, and you will if when you're dealing with multiple functions in a problem. You can use G, H, little f are all most popular choices. You can also use, if you have more functions, use capital F, capital G, capital H. But the way this works then is for y, I can now write this function notation, f of x equals 2x plus 3. And it's called operator notation. So at the end of the day, nothing's really changed in terms of, finding order pair solutions for that equation of 2 variables. This is still a line with a slope of 2 and a y-intercept of 3. It's just, we've now established it's this thing we call a function. And say I wanted to, what would the order pair solution be if I had an x coordinate of, say, 3? So I'm trying to find f of 3. And so inside here is your input that goes into x. So the x coordinate is 3. So to find its corresponding y value, or f of 3, I put in 3 and I do the arithmetic, and I'm going to have what? 9 in this case. So the order pair solution is still 3, 9. It's just we are now viewing it in the lens of being a function. Okay. Any questions thus far?
No.
No.
Seem like, yeah, this is stuff we've done before.
Yeah.
Yeah.
Okay. All right. Well, let's do this. Let's say I have a function, f of x equals 3x plus 2. And I asked, what is the domain? And right now on this section, you're just going to be establishing domain. So remember, domain is the set of all the x coordinates. So at the end of the day, when you're given something like this and ask, what is its domain? You start with a set of real numbers and say, is there anything I need to throw out? And what would cause that to happen? There's really, at the end of the day, only 2 things that could be a problem: division by 0, or trying to take the square root of a negative number. If you don't see either of those 2 things, then your domain is all real numbers. And we're going to represent the domain in interval notation. So if it's all real numbers, it's negative infinity to infinity. So any linear function is going to have a domain of all reals. Again, so the 2 things that you would look for, is it possible to end up dividing by 0 if you input some value x, or is it possible to get a negative value? So let's look at those 2 cases. Let's say I had f of x is 4x plus 2 over, oh, I don't know, how about 5x plus 10. All right. So if I were to look at this one and say, what is the domain? I don't really care about the numerator in this problem because the numerator can be 0. What can't happen is the denominator cannot be 0. What number would cause division by 0 in that function? There's just one.
-2.
-2. And so what I'll say is the domain here is all reals, but -2. -2 would not be possible. Interval notation, it's a little cumbersome. You got to just say negative infinity up to -2. And I put a parenthesis because that means I'm not including -2 union with -2 to infinity. Now you will see sometimes set builder notation used here. And it would look like this. It's actually a little simpler. X such that X does not equal what? -2. Okay, let's look at another one. Let's use g of x. This time, something different. Square root of x plus 5. Now here, what we know is we can't take the square root of a negative number. That's going to give me a complex number. So what I will do is I'll say, well, I just need to have values of x such that x is what, or x plus 5, excuse me, what's underneath their square root is greater than or equal to 0. So that would be x is greater than or equal to -5. So your domain here, interval notation, bracket, -5 to infinity. Questions on that one?
I don't think
I don't think so.
Okay, so if you have, this is what's called a rational function. You're just trying to figure out what would make the denominator equal to 0 and toss out either that 1 or 2 values, or maybe even 3 that would make that happen. But it would definitely be a finite number of values. If you have a radical function, a square root function in this case, you need to figure out what makes that radicand greater than or equal to 0. And that will end up being the domain. So I'm going to give you one more. I'm going to have you guys look at this one, see if you can tell me what. I'll go h of x. And this one I'm going to have, I don't know, let's go with 5x plus 8 over the square root of x minus 2. All right. So we still have a couple minutes. So go ahead. See if you can figure out what the domain of that one will be. All right. We have an answer?
Yeah, I don't know right though.
It's okay. So what'd you get?
Okay, so the bracket to an infinity.
To infinity. So you answered this.
Yeah.
Okay. You are close. You're really close, but it's off a little bit, which is why I wanted to do this one. This one's actually kind of combining both things. You've got variable in the denominator, and you've got the square root in the denominator. So the only issue I would say is you took the x minus 2 and said, well, I need that to be what? Greater than or equal to 0. But actually, on this one, it's just strictly greater than 0. The problem is if you put 2 in, and this notation right here with the bracket means include the 2, you're going to have 2 minus 2, which is 0, and you're going to have the square root of 0, which is 0, and that's in the denominator. So in this one, you want to not set it greater than or equal to 0. You want to say strictly greater than 0, because you can't include 0 because this is living in the denominator. So your answer here would be parenthesis 2 to infinity. Make sense?
Yeah.
Okay.
So when do we not include, when do we do just greater than or less than and not equal to?
If it's in a fraction.
So if it's in that denominator,
Okay.
that's why I did not want to put greater than or equal to 0. If this had been living in the numerator, then I could put greater than or equal to 0.
Okay.
All right. So then again, I'm giving this a quick review over in this section. There's 2 more things in here that I haven't talked about. So I'm going to do one of the 2. You'll see problems like this going back to evaluating for functional values. So as an example, if I have a function f of x and it is, let's make it linear, 3x plus 5. And I was asked to find f of 0, then I don't think this is going to be any problem for you guys. Then it's going to end up being what, 5. But you will have other problems where you're asked to do something like this. Find f of the opposite of x. And so here you have to input negative x everywhere I see x. So that would be in this case 3 times opposite of x plus 5. And then simplify as much as you can. So the only thing I could really do is call this negative 3x. And I'm done. I'm going to do one more. This one's going to look really crazy. F of x minus h. And initially for students, the first time they ever see something like this, the abstractness of it takes a little bit of time to wrap your head around. What you have to do is think of this as an open box, and whatever I have here, that's what I put in here. Sometimes the students get confused. They see an x here and they see this x and it just doesn't connect. You would literally just have this input x what minus h plus 5. And then simplifies me. All you could do is distribute to 3. That would be it. All right. This last thing I'm doing here, this is a precursor to something that looks like this. And you're actually going to have x plus h. And I didn't mean to draw out a 3 there. This is going to be 3x plus 3h plus 5. That's as much as I could do. We're going to deal with next time something called difference quotient, which actually takes us right up to the edge of calculus. And we'll talk about why that is next time on Thursday. So with that said, I'm going to go ahead, and this is what I did last night with my campus course. I'm going to assign 3.1, but I'm going to put the due date a week from today.
Okay.
So if you want it, but before you get into 3.1, I want you to I want you to make sure you finish 2.4, take the quiz, and take the chapter 2 test. Again, this is at home at least once, so that you get that caught up before you get into 3.1. So if you're not able to get to 3.1 before Thursday, it's okay. All right. After class on Thursday, I will have covered everything in 3.1. So any questions?
No.
Okay, let me go ahead and